Hello students, welcome to today's class. So today we'll see the theory part 5 of the chapter 8 organic chemistry, some basic principle and techniques, in which we will be covering NCERT section 8.5. So this is the disclaimer. Now in this class our objective would be to name the compounds according to the IUPAC system of nomenclature, and we will also use it to derive their structures from the given name. So you will learn in both the ways. First of all, you will be able to give IUPAC name to a given compound structure, and from a IUPAC name you can also write or draw the structure of the compound. So you should know both of them. We will learn about this, what is your IUPAC system and all, in the upcoming slides. If I talk about the specific sections of the NCERT that we will cover, then it would be section 8.5, nomenclature of organic compounds. Then after, in this part, we will see IUPAC system of nomenclature. So this is the system that is used to standardize the names of all organic compounds, which is IUPAC system. Then will be specified to this nomenclature of alkanes. Okay, so alkanes is a special group of organic compound which obviously do not contain a double bond or triple bond. So those are called as alkanes. We will learn about them in the hydrocarbon chapter. After that, we will try to just complicate things by adding functional group to that alkane chain and try to name it according to the IUPAC nomenclature. So let's start with the basic idea of why we need to do the standardization. Now, this IUPAC nomenclature is basically a standardized system for naming chemical compound, and its full form is International Union of Pure and Applied Chemical Science. Okay. Now, before this IUPAC name, we have different names, and we call them as common names. Now, these names were though useful, but can create confusion because in one part of the world someone is using a different common name, and in the other part of the world someone is using another common name. But to make it more available to everyone, we have to choose a standard naming system, which we call as the IUPAC nomenclature. So let's see first of all what are the common names that were initially given. So here are some formulas. Along with them, I have given their common name. So we have CH3 whole twice CH3. So this is named as isobutane. Now you already know how to write the expanded structure from the condensed formula. You can just try this thing out, and then you should see that what is the structure, and that structure will be called as isobutane. If I just define it, how do you write it? So you can see that there is one carbon, and to that two methyl groups are attached on the left hand side. On the right hand side, the third methyl group is attached. So basically this is a 3-member ring with one branching. Okay, just you can just see this. So 3 not 4-member ring. Yes, so with a branch of methyl. Coming on to the next one, we have neopentane. I will just show you the expanded structure in the upcoming slides. So here we have one carbon, and to that 4 methyl groups are attached. After that, we have a common name for a compound containing functional group also. So this is aldehyde, the smallest aldehyde, HCHO, and the name which is given to it is formaldehyde. Lastly, we have an example of ketone. So this is acetone, where we have a CH3CO group. Now this CH3CO group is often named as ACET. So we have acetic acid for CH3COOH. Similarly, we have acetic anhydride, and here we have acetone. So whenever you see a CH3CO group, you use this ACET before naming it. Okay, so this is a common thing. You will notice it when you will encounter more and more chemical common names. Okay, now let's start with the standardization. So this is where the common names. We will start with straight chains. What do you mean by straight chains? So these are the simplest chains where we have a single line and that line is not branched with other carbon. So we have a straight chain, as simple as that. We can take some examples also. To before that, you should know the rule to write the names of this simplest carbon compounds having a straight chain. You just have to use the suffix A and E, okay, for saturated chain of hydrocarbon. Remember, it is for saturated chain where we don't have any double bond or a triple bond, and that suffix which is used for it is A and E. Okay, so we have suffix for double bond and triple bond also. We'll talk about them. So examples of it would be, so here are 6 examples starting from methane. So this is the smallest straight chain possible. Moving on to ethane, which is C2H6. Then we have propane, butane, 4 carbons. Then we have pentane, 5 carbons, 6 hexane. Okay. Now on the right hand side, you can see some longer chains like heptane, octane, nonane for 9 carbon. Then we have decane for 10 carbon. Similarly, we can have for it, for 20 carbons, icosane, and triaconatane for 30 carbons. Now these are some common straight chains. You will encounter this in the upcoming slides, but still this is the simplest one. We don't need any branching rules for it, but in the upcoming slide we'll see the branching part also. First, you should remember what is the name given for number of carbons, right? So for 1 carbon we give it methane, 2 we give it ethane, then propane, then 4 butane, 5 pentane, 6 hexane, and so on. So we'll next move on to this branched alkyl groups. So the organic compound which contain branched alkyl groups. So here is an example for that. Yes, so we have a general idea of naming such compounds. So still we are not including right now the functional groups, but still you can use this for branched alkyl groups or any other complicated organic compound. So this is a rule. So first of all, we have 5 parts: secondary prefix, primary prefix, word root, primary suffix, and secondary suffix. You will see first of all what are the things that are present. Then you will add them in the given manner to get your final name. Now what does each stands for? We will see them one by one. So first is secondary prefix. So this secondary prefix is used for the substituents that are attached to your main chain. Now in this case, where we don't have any functional group, we use it for alkyl groups like your methyl or your ethyl or your pentyl and so on. Second thing is the primary prefix. So this is used when you have a cyclic compound. So after your secondary prefix, we have the primary prefix. Now you already know what is cyclic compound. Those compound which contain a ring. Okay, that can be 5-membered, 3-membered, 4-membered. We have different way to name them. Okay. On the third part, you can see the word root. So secondary prefix, primary prefix, and then the word root. Now this word root will be followed according to the previous table which we have seen. So for 1 carbon, you can use the word root meth, then for 2 carbon eth, and accordingly you can add the suffix. So right now we are not telling what is the suffix used for different bonds like double or triple, but the main thing is that you should at least remember the root. Like your 5 carbons has a pent root, PENT. We will see onto it. Again, what are the things that are left? We have covered secondary prefix, primary prefix, word root. Next come your primary suffix. So it will indicate the type of carbon-carbon bond. As I said, if you have a single bond, you will use the suffix, primary suffix as A and E. If you have a double bond, at least one, you will use E and E, which is ene. Then we have it for triple bond, which is YNE, which is ine. And the last is secondary suffix. So this is used to indicate the main functional group. Now, we are not till now into this functional group thing. We'll talk about those. So you will see that if a given compound contains multiple functional group, so the one is chosen as the main functional group and the other are given as subsidiary functional group. And the alkyl group is being assigned your secondary prefix. So in place of that, your subsidiary prefix is used if it contains multiple functional group. We will talk about that. But right now you should know at least the primary prefix, secondary prefix, the word root and the primary suffix. We will see them. Now let's start with some examples. Before that, we have a thing. So how do we name the secondary prefix for different alkyl groups? There is a rule for that, very simple one. So let's start with the rule. Now this is based upon the branched carbons which are a part of the main chain. You can say which are attached to the main chain, not a part of the main chain. So they are present as branches. How do we name them, the branches? It's very simple. They are derived from the alkane name. You have to just remove one hydrogen. Suppose we have a methane. If you remove from one hydrogen from there, so that will be converted into a branch. How do we name them? So it's very simple. You just have to replace ane with yl. Like if you have replaced one hydrogen from methane and you got CH3 and now that is attached to a straight chain, right? So that is not part of that main chain, but it is attached to the straight chain. In that case, you will be calling your branch as methyl by removing ane with yl. Now, in place of that, in place of using the IUPAC name like your methyl, ethyl, propyl or butyl, we have some common names also for this side branches. And this common names can be used in the IUPAC nomenclature. So this is very, very important to remember. Now, what are those special type of groups? Yes, these groups are very, very important in two ways. First of all, you will be asked to write the names of this given branches. Second thing, in exam, you will notice that question is framed with the help of these common names for branched alkyl groups. And in that case, it can create a confusion. So for that reason, you must remember this specific branched alkyl groups. Starting from the propyl, you know it. It's a simple one. We remove ane and write as yl, so propyl. But if you see the next one, it is isopropyl. Now this is composed of 3 carbon. So we are using the same propyl word here. But your connection is somewhat different from the first one. It is not a straight chain. So here, 1 carbon is the middle. 2 methyl groups are attached onto both sides. And your propyl group is not attached from the end, but it is attached from the middle carbon. And that is the reason we call it as isopropyl. The third one is neopentyl. Now this is coming from pentyl, so it will of course contain 5 carbons. You can count them, but the chain is not linear, means not a straight pentyl chain is directly attached. You can see a carbon in the middle with 3 methyl groups on the 3 substituent part, and the fourth part is again a methyl, and that methyl is instead connected onto the main chain. In that case, we call it as a neopentyl. Then we have butyl, simple butyl. But if you are connecting the butyl not from the end side but from the second carbon of the either part, then you call it as sec butyl or secondary butyl. Then again we have isobutyl. You can also see there is a difference in the normal butyl and the isobutyl, although the number of carbon is same. Lastly, we have tert butyl, where your middle carbon is attached to 3 methyl groups and the fourth substituent is been missing. So this is the part where your main chain will be attached to it. Now this tert butyl is a tertiary butyl because the carbon in the center is attached to 3 other groups. So now we can move on to specific examples. We have talked about the rules. So what is the example that we'll use? So this is the one. We have a long chain and there are branches also. So first you have to decide that which is the longest chain. So there is a proper way to do the nomenclature. We will move one by one. So as I said, you should first know that what are the things that are present here. Now this given organic compound is containing branches. So that is for sure. You can look here. It is not a straight chain. Of course, it will contain a word root, so that is mandatory. Your organic compound will be of some length. It can't be of zero length. So the word root is present in each and every compound. Third one is primary prefix, primary suffix. So that is used for single, double, and triple bond. Accordingly, since we have a single bond, of course, we will use the A and E. So this is also a kind of mandatory one because either it will contain single or double or triple. It is not possible that it will contain a zero bond or a four bond. So that is a hypothetical case and not possible at all. So this is also a mandatory one. So the extra thing that is present is the branches apart from the normal straight chain. Okay. What about the other parts? So we have two parts missing. We don't have any cyclic ring in the given structure. So no primary prefix. Second thing, we don't have any functional group. So we don't have any secondary suffix as well. Now we have to look for these three parts and then add accordingly to make the complete nomenclature. So this was our compound. In the compound, how do we decide the word root? So now listen very carefully. First, you have to identify the longest chain which is possible in your given compound. Now the longest chain is given here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the longest chain possible. You can try another combination also. Suppose you start from left and instead of moving straight, you go on to the branched part. So you can start 1, 2, 3, 4, 5, 6, 7, 8. Now this will contain 8 carbon, which is of course not the longest one because the longest one is containing 9 carbons in total. So if the longest chain is containing 9 carbon, then we can say that the word root will be known. Remember, from the straight chain with 9 carbon was given no name. So the word root must be known here. Let us move on to the second part, which is primary suffix. How do we decide it? By seeing whether there's a double bond or a triple bond or a single bond. So there is no presence of any double bond or triple bond. All bonds are single. So that will make sure that the primary suffix is A and E, which is used for single bond. So we got word root, we got primary suffix. The third thing that we require is the name of the branches. Now let us move on to that. How do we do it? So the way to do it is numbering. See, you have two options to number your longest chain. So this was your longest chain. So there are two options now. Either you can start from left or you can start from right. So first, let us see what are the options. So A option give you substituents on 2 and 6. You can see it very clearly. We have a substituent on 2, a methyl substituent. On 6th position, we have ethyl substituent. Now in option number B, if you just reverse your numbering, the substituent is on 4th position and on 8th position. So let me give you the correct one. So here the correct one is, which one? It will be A. What is the reason behind it? Why option A is correct? So there is a very simple rule to do it, which is called as lowest sum rule, according to which you just add the substituent numbering. If you add it for the option A, then it will be 2 plus 6, which is 8. If you add it for the option B, it will be 4 plus 8, 12. The lowest sum will be chosen accordingly. So the lowest sum is in option number A. Therefore, the correct way of numbering is option A. You start from the left with 1, 2, 3 and move on to 9. So this is the correct and the easiest way to do the numbering. Now what is the next thing? So we were upon our finding of the branched naming. Okay, so alkyl branch naming is been left. But before that, you should do the numbering. Then and then only we will be able to give name from the give name for the branched alkyl groups. Okay, so now we are in the state of deciding secondary prefix. So this was our longest chain. So we call it as no name because we don't have any double bond or triple bond. We already seen it. What about the substituent? So one of the substituent is present on the second group. If you do the lowest sum, you got it on the second group, which is methyl. And on the sixth position, we have the ethyl. So we can say that at second position, due to position of methyl, you will call it as 2-methyl. Similarly, on the sixth position, we have a ethyl, so we call it as 6-ethyl. Therefore, we can simply write the complete secondary prefix. Now, there is a way to write it. What is that way? You have to use the alphabetic order. So, two substituents are there, ethyl and methyl. And since ethyl starts with E, which comes first in the alphabet, then M, therefore, we will write 6-ethyl first and then we will write 2-methyl. Here is a small note for you. You can see hyphens in between. So whenever you see a second substituent other the first, you should be putting hyphens on both sides. Like we have hyphens on both sides for 2. So the complete secondary prefix would be 6-ethyl-2-methyl. Now we have all 3 required parts. So we can just add all of them to get our complete nomenclature. So let's see how can we do it. So this was our order: secondary prefix, then word root, then primary prefix, suffix. Rest of the things are missing in this, so we'll not mention them. Therefore, we'll add 6-methyl, 2-methyl, and then non, and then ane, giving your complete name as 6-ethyl-2-methyl nonane. Remember to put hyphen. So this is a note for you. Okay, so you have to put hyphen before your substituent name and after your numbering. And if the numbering is coming in between, you have to put hyphens on both sides of the numeral. So this is the way you will name your branched alkyl groups. Moving on further, the first type of branching that you saw in the previous slides contains branches of simple chain. So basically, you've seen a methyl and a ethyl. So they were simple straight chains that were attached to the main chain. In place of that, you can have complex branched alkyl groups. Now you have two options if you are doing the nomenclature. Either you can use the common name if it is available for the given complex branch alkyl group, or you can have a way to do it. So we'll now learn about that way. Now a very special case is used here. What is that case? You have to provide a secondary numbering for those complex branched alkyl groups. So you can say that your smaller subsidiary chain is like a smaller carbon chain. You have to provide a separate numbering for it to name it properly. What can be the example of this complex branch alkyl groups? You can see here, this branch that is down here is a complex type because it is not a straight chain. The straight chain is 1, 2, 3, 4, but that 4 carbon containing side chain is also containing 2 methyl groups. Okay, now you don't know what is the main chain, but we are assuming that this is the side chain and then we are saying it. We'll see that how the side chain will be decided. There is a way for it, but still, if you notice the side chain also, suppose I keep it as the part of the main chain, then this will be the part of the side chain. Then it is also containing a complex structure. The branch is not a linear one, it is a branched one. How do we name it? So there is a way to it. We have to number it separately, but the procedure is same. Rest of the procedure will be same. We just have to deviate from our previous procedure a little bit to name that branched alkyl group. So this was our example. Okay. Now what are the things that are present? So it will be similar to the previous one. There is a branch second, so we will use it for providing the secondary prefix. The word root and primary suffix is compulsory, so those will be there. We still don't have any cyclic chain and we don't have a functional group. Okay, so they are not present. Now moving on further, we will first decide the word root. Here two chains are possible. Now why two chains? Why I am referring to two chains? Because they are of same length. You have to decide the longest chain. But if you just count them, these two options, then they both have the same length. Okay. What is that length? So here that length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a 10-membered chain is there. Similarly, here also we have a 10-membered straight chain. But we have to decide one parent chain. So that is decided on the basis of number of branches. You have to decide which one is containing greater number of branches. Now, since both of them have the same length, but one is having a greater number of branches, and that one is A. Therefore, you will say that your option A will be the parent chain. But remember, we don't have to worry about the word root. It will be same for both of them because the chain length is same, but the substituent will change for both of them because the number of substituent is more for the option number A. So moving on to the next. Now we have decided our longest chain. Our next task is to search for primary suffix. There are no carbon-carbon double bond present in the given compound, so that makes sure that your primary suffix is A and E. What is the next thing? The most important one is to name the complex branched alkyl groups. To do that, we have to first do the numbering. Now, we will again use the lowest possible set of numbers to number it. The two ways that are possible are from the left side starting and right side ending. In the second option B, we have right side starting and left side ending. Now in both of these options, which one will be the correct one? Obviously, the option B will be correct because it will result in the lowest sum. You can just count it. For the option number A, the total sum is 22. And for the option number B, the total sum is 11. Therefore, the lowest sum is 11 and hence the correct option is B. So we'll number it according to B. Now moving on to the next. We have to now decide your secondary prefix. Now two of the substituents are easier to name. So those are methyl groups because they are simple chain. But if you look onto the third substituent, which I have named it as 2-ethyl butyl, so that is somewhat difficult to do. Let's see how we can do it. First of all, we give the name for your 2-methyl substituent, so they are both are present on third position. Since 2 are present, we will write it as 3, 3 for 2-methyl groups, and we will use the word di to represent their times. So this 3, 3 is representing their position for both of the methyl groups, and since there are 2 methyl groups, we write it as di. So 3,3-dimethyl. Similarly, you can use tri for 3 and tetra for 4. Now coming on to the complex branched alkyl group. How we'll do it? So basically the first part is to do the numbering. We already are done with the main chain numbering part. We have to do the numbering for the side chain. If you see onto the side chain, it is connected with this carbon. Okay, so we number the point of attachment as 1 dash. Okay, so this is given as 1 position, and to keep it separate from the numbering of main chain, we can use a dash here. So 1 dash, or you can simply add 1 also. Then if you start it from here 1, and then from here you do the longest possible numbering. Okay, so you find the longest chain, but the numbering will start from the point of attachment, that is for sure. So 1, 2, 3, 4. So either you move in this straight way or you move like this, you will get the same number of side chain, okay, and the same length of carbon. Now if you do numbering in this way, then on second position we have this ethyl. So how you will name it? 2-ethyl for this branch of this branch. So two things are there. So there is a branch and there is a branch attached onto this branch. Therefore, we are naming it as complex branch alkyl groups. Now for the main branch, you will give it as butyl because 4 are present, but still you will not write butane. It is a part of branch and not the main chain. So completely you can write it as 2-ethyl butyl to name it. Now on which position this is present, on which carbon it is present for the main chain, it is present on the 5th position. So 5 dash, then in the bracket you write it as 2-ethyl butyl. So this is your complete numbering for the branch present on 5th position. Now you have to keep them in the alphabetic order. How we'll do it? One thing you have to remember, it's the most important one. You will not consider di, tri or tetra while placing them in alphabetic order. Now if you just keep that inside, you have two substituents. On the 3rd position, the methyl is starting from M. Whereas you're on the 5th position, your 2-ethyl butyl is starting from E. You know it very well. E comes before M. Therefore, your complete secondary prefix will be 5 dash, then in the bracket, 5 hyphen, then in the bracket 2-ethyl butyl, bracket close, dash 3, dash dimethyl. Now we have the substituent. We have the complete parent chain length. We have our N as the suffix. So we can just arrange them accordingly to give our complete nomenclature. So let's do it. If you just add them, you will get it as, for secondary prefix, we have 5 dash 2, 5 hyphen 2 dash hyphen ethyl butyl, bracket close, then hyphen 3, 3 hyphen dimethyl, plus word root is dec for 10-member carbon. Then primary suffix is N because no double bond is present. So your complete name will be 5 hyphen 2 dash hyphen ethyl butyl, bracket close, hyphen 3, 3 hyphen dimethyl decane. Now the importance of hyphen is very much. You can see that on various positions we have hyphen present. You can see here. Now one place is there where hyphen is not present, that is between two numerals. But as soon as you see that the numeral is after or before your alphabet, you have to put a hyphen in between to separate them. But to separate your numerals, you have to put your comma. Got it? Now moving on to the 3rd type of nomenclature, which is used for functional group. I would not name it as a type. You can just see it as a extension. So your functional group is already been defined. It is basically a group of atoms or a specific atom in some cases, which show specific properties due to their similar connectivity. Okay, so that property can be chemical and physical as well. So compound with same functional group often exhibits same chemical behavior, due to which we have to specify them separately with a different kind of nomenclature. If you again take that example, you have seen those functional group. We have a hydroxyl functional group and we have a halide functional group. Let's see how we can name it. Now this Br is for bromine, and this OH, which is hydroxide, it belongs to a specific functional group named as alcohol. as long as it is attached to a straight chain. In case of benzene, it is given a different name, phenol, different functional group at all. But in case of aliphatic chain, if the hydroxyl group attached to aliphatic chain, we will call it as alcohol. Here are some examples of functional group. If we have a double bond between two carbon, the functional group is alkene, triple bond is alkyne. So if a nitro group is present, we call it as a nitro compound. Similarly, for COOH, we have carboxylic, sulfonic acid for SO3H, and so on. Now, there are proper prefix and suffix given for them. When to use its prefix, when to use its suffix, we will see it. But if you just list them, for the nitro group, we don't have any suffix at all. Similarly, for the double bond and triple bond, we don't have any prefix, it is ene and ine. But if you consider it for the carboxylic acid, it has a prefix as carboxy and suffix as oic. Similarly, for alcohol, the prefix is hydroxy and the suffix is ol. For aldehyde, the prefix is formyl and the suffix is al. For ketones, the prefix is oxo dash and for suffix of ketone we have on. For nitrile, which is C triple bond N, the prefix is cyno and the suffix is nitrile. So let's see how we can name the compound containing functional group. In the first case, we will take a chain that contains only one type of functional group. Here is an example for it. You can see that it is containing only ketonic functional group. The C double bond O, this is representing your ketonic functional group. How do we name it? We'll use the similar imprint. First, you will see whether the secondary prefix is there or not. Primary prefix, word root, primary suffix, and secondary suffix. We will check for all of them. We know it for sure that primary suffix and word root are mandatory one. You will see in each and every case because it will have a length and it will be either saturated or unsaturated. So there is no option to be in a third position. Apart from these two, we have a secondary suffix. Okay, now in this case, there is no branching present and you will see it when we search for the longest chain. It's very obvious from the structure as well. But we have a functional group. I would say two functional group of the same kind. So you have to use a secondary suffix for that. Of course, due to absence of cyclic group and your branching, you don't have any primary prefix or secondary prefix. As I said, you have to follow all of the rules of the previous part, and in addition to that, you have to do some extra things for the functional group. So starting from the first thing, which is this decision of the word root. It's very easy. If you identify the longest chain, there is only one chain possible, and that chain is of 6 carbon length. Therefore, the word root will be hex. Now we will search for primary suffix. Again, it's very easy. There is no presence of carbon-carbon double bond. Okay, one very important thing. You can't look for double bond only. You have to look for a carbon-carbon double bond to name it as ene, or as for triple bond, you have to name it as ine. Okay, there is a presence of unsaturated carbon, of course, but that unsaturated carbon is being attached with double bond to O, not to any other carbon. So there will be no carbon-carbon double bond present. Therefore, the primary suffix is ane. So we got two things. Now our next target is to define the functional group. How do we do it? For that, you have to decide the numbering first of all. Now again, we have two options. You can do it from the left, you can do it from right. But if you just see the lowest possible sum, then the correct option will be B. Because if you see it for the option number A, the addition gives you 8. So 5 plus 3, it gives you 8. Whereas if you see on to the right hand side, the option number B, the addition gives you 6. Okay, therefore the correct numbering is according to the option B. Moving on further, the next thing is to decide the secondary suffix. We have done the numbering. To decide the secondary suffix, you can clearly see that there are two ketonic groups. For these two ketonic groups, the position is at 2 and 4, and they are repeated twice. First of all, we will give numbering for both of them. So this is present on 2 and 4, so 2, 4. Then to separate numeral with alphabet, we have a dash, and for two ketonic group, we have di. So 2, 4, 2, 4 dash dione. Further, we already have all the things that we required to name this compound. So we have the word root, we have primary suffix, we have secondary suffix as well. So hex plus ane plus 2,4-dione gives you your complete name as hexane dash 2,4 dash I dione. So this is your complete nomenclature. What is the second type? The second type contains more than one type of functional group or polyfunctional compounds. In this case, you will have a secondary suffix and a secondary prefix. Now, how do you decide which one is secondary suffix and which one is secondary prefix? It's very simple. So secondary suffix and secondary prefix is done on the basis of priority order. So this is the priority order. You don't need to remember a long one. Only you need to remember this given priority order. And if you know that which one is having a higher priority, then you will give that functional group with higher priority as secondary suffix. Whereas the lower priority is kept as secondary prefix. So it will give the compound its secondary prefix. So let's take an example to understand the numbering for nomenclature for polyfunctional compound. For example, we take this given compound. Here we have to decide that what are the things that are present here. If you look at this compound, you can see it very clearly that except your primary prefix that is used for cyclic containing compound, all of the parts are present. Because of two functional group, we don't need any alkyl group for giving the secondary prefix. Okay, so the subsidiary functional group will be deciding one for the secondary prefix. Then for secondary suffix, primary suffix and word root. So these three are also present because two are mandatory and one is present due to presence of two functional groups. Remember this part now. The secondary prefix is for subsidiary functional group, the lowest priority group, and not the alkyl group. So this is a change now from the previous discussion. A small change. So initially you were using the secondary prefix for alkyl groups that are attached to the main chain as branch, but now you are using it for the subsidiary functional group in case of two functional group present. What is the first thing that we do? We have to provide the word root. To do that, we decide the longest chain. So this is the longest chain possible. Remember to include the carbon that is a part of the functional group. If you do that, the longest chain is of 6 carbons. Therefore, the word root is hex. Moving on to the primary suffix. Again, there is an absence of carbon-carbon double bond or a carbon-carbon triple bond. Therefore, primary suffix is ane. Then in the next, what about numbering? So numbering can be done in two ways. Now here's a twist for you. In this case, you don't have to go with the lowest sum rule. Instead of that, numbering is done in such a way that your primary functional group or your functional group with higher priority gives the lowest number. So that is the rule. That is the thumb rule you have to follow here in case of presence of any functional group. Again, I am repeating it. If you have a functional group, if it is a single functional group, the numbering is done in such a way that your functional group gets the lower numbering. If two functional groups are present, the numbering is done in such a way that the functional group with higher priority is given the lowest numbering. Here, if you follow that rule, the correct option will be B, because the principal functional group COOH is getting the lowest number, which is 1. Okay, so in this case, the lowest sum rule is not followed. If you add the sum for the option A, it will be 2 plus 6, 8, and on the right hand side is 5 plus 1, 6. Okay, so in this case it is followed, but remember, it is not followed everywhere. Okay, in this in case of functional group, you have to look for that numbering that gives your functional group, or in case of polyfunctional group, the principal functional group as lowest number. Now moving on further, next you have to decide the secondary suffix. How you will decide it? It's very simple. The secondary suffix is decided by the primary functional group. So which one will be the primary functional group? Your carboxylic group, okay, which is present at first position. Therefore, the secondary suffix will be oic acid. You can just refer to that table for the suffix. What about the subsidiary functional group? It is present at the 5th position, and that will decide the secondary prefix. Now, according to that, we know it very well that the ketone is present there. Therefore, your secondary prefix will be oxo with a 5. So 5 is describing again the position. So 5 hyphen oxo. So you got your all the parts. What are those parts? You got your secondary prefix, you got your word root, primary suffix and secondary suffix, which is 5 oxo, hex, then plus ane plus oic acid respectively. If you add all of them, you will get your complete name as 5-oxo hexanoic acid. I hope you are getting the point. Let us summarize all of today's discussion. Now we are left with some part of nomenclature, which is again your cyclic ring. We have not dealt with it till now. We will see it in the next class. For now, I hope you got the nomenclature for aliphatic chains. So this was the scheme that we followed throughout this nomenclature part, in which the secondary prefix is decided by the alkyl group. In case of polyfunctional group, the subsidiary group can also decide this. Then we have primary prefix, which is indicating your cyclic group. We'll see about it in the next class. Remember, if you have both your branching and your polyfunctional group, then the subsidiary functional group and your branch both will be combined together to give your secondary prefix. You will use the alphabetic order to write them in proper way. Then the word length, it is decided by the length of the main carbon chain. Then we have the primary suffix, which is decided by the type of carbon-carbon bond. For double and triple, we have ane and nine if carbon-carbon double and triple bond is there. And for single carbon-carbon bond, we have a ane as your primary suffix. Lastly, we have secondary suffix, which is used in case of a functional group presence. So it can be poly or it can be single. Remember, the presence of polyfunctional group is cared of by taking your primary functional group, or you can say principal functional group, as your secondary suffix. So this was the case. If your compound is containing more than one type of functional group, then your secondary suffix is decided by the highest priority order functional group or your principal functional group, whereas the secondary prefix is decided by the functional group which is at a lower priority. And this is the priority order. Carboxylic acid is the first one, then the SO3H, then COCl, then aldehyde, then your ketone, and then your lastly your alcohol. So this was all for today's class. I hope you enjoyed the session. Thank you for joining it.